Hey there everyone, Professor Steve here. And so welcome to our next lecture on human-ocean interaction. And really the theme of the interaction is how do humans use the ocean as a resource. Um, and really this will just be a brief lesson on what's relatively straightforward. And we're still working on essentially physical resources, and definition of a physical resource are ones that we physically remove from the ocean. And this whole last set of physical resources that we're going to go over are pretty intuitive stuff we can understand without too much explanation. Um, and so the second is for strengthening or for presentation of building materials. But sand and gravels and stones are additives in cement. We use sands to make glass. Um, Certain types of gravels and grains are added to animal feeds and a bunch of other things like that. The way that we get these things, there's several different ways. There are different ways of different types of what we call grabs, and these are just what they sound like. They're giant, essentially claws or grabbers that we lower down and hoist buckets of stuff up, and then we sift through it and sort it and clean it. Um, but the more common way for getting a lot we call dredging, and this is when we either um, or we sort of lay out a platform in boat type form or in a more traditional sense of the word platform, and then we use either belts, digging, use hydropower, so water, and we'll put down a conveyor belt or more commonly a vacuum of some sort where we blow water at the sand and the silts and it kicks it up, and then we have a vacuum that kind of sucks it up onto these dredging platforms where they're run through various different types of things that sort them into the size and type of resource that we want to collect. The second one we're going to go over in this lesson is another relatively obvious one. What's in seawater? What makes the seawater salty is the salt, right? We use salt for many different things. Some of them, again, obvious, some of them not. But table salt, sodium chloride is the salt that we use on our table and put on our foods. And many of us um, essentially buy sodium chloride in a synthetic version, a kind that's made and treated and iodized. But you can buy sea salts, which are said to be quite a bit healthier for you because they're not synthetically made and they're not treated with anything. So then all the other combinations of anions and cations make up different types of salts that are used for different types of things, right? We're familiar with this one, calcium carbonate, which makes shells, but we use this to make chalk. We use this to make building materials. Calcium sulfate, also used for building materials. Gypsum is, I'm not sure if it is anymore, but at one time was the main ingredient in sheetrock, the stuff that they used to cover walls and buildings with. And sometimes various combinations of the magnesium, potassium, another one, some others, bromine, which is a more of a trace element, but an important one for some biological processes. Some of these forms in salt form, but also some of these on their own are used in all different kinds of human processes. We collect them, use them for chemical formulation, for health supplements, some medicines, sterilizers. Some of them are additives and fertilizers and gasolines and these kinds of things. So, how do we get the salt from the water, from the ocean? And really, it's sort of the tried and true method, and that is through evaporating the water away from the salt. So the idea is you collect ocean water in a segregated area. You close off that area and keep it from getting any kind of fresh water input. You keep it from getting any kind of fresh seawater, or I should say new seawater, and you let that pond evaporate. And as it evaporates to a certain extent or to a certain at certain temperatures to a certain a bit of water removal, you can sort of funnel the water off, as you will, into another pond. And so if you know the dynamics in which it takes to sort of um, evaporate off the water and leave behind a certain salt, you can sort of selectively evaporate one salt in one pond, move the water to here, selectively evaporate another one, and so on and so forth, so that you're collecting the salts behind as you evaporate the water away. And so that's why they're called salt ponds. The last resource we're going to talk about, physical resource, I should say, is fresh water. So it's salt water. If you remove the salt, what's left behind? Fresh water. And fresh water is one of the more important, potable drinking water is one of the more important and highly limiting resources on Earth. There's still plenty of areas that just can't get enough drinking water. Um, and essentially, we do this through many different um, or a handful of different methods that are all considered to be desalination, so the removal of the salt from the water. Um, Using these salt ponds is not actually one of them, as far as I know anyway. I don't think anybody actually collects the water at the back end of a salt pond, uses it for drinking. But we tend to use different, uh, different, a couple of other processes that sort of more make sense, which is one is to force boil the water off, leave the salts behind, and collect the fresh water. And that process is called distillation. So distilled water is water that's been force evaporated by heating it most of the time. The second one is you can freeze the salt water, right? If you freeze it, if you take frozen water, um, if you freeze it, we know now that it expels the salts, right? We have salt exclusion or salting out of that seawater, and you have fresh water left behind in ice form. Then you just need to collect the ice and melt it. And then another process is reverse osmosis. Um, so distillation is essentially a boiling. You run the water through here. You have a series of channels that sort of run the water from that cause the water to channel from place to place, and as you boil it, it vapors and is funneled into a next collector and a next collector, and you collect the salt, the saltiest part of the water, and then finally salt crystals, and have this very briny soup that comes out one end, and essentially um, you catch the condensated completely fresh water in these funnels, and you have an effluent of fresh water. So what I said about freezing is true, except nobody really goes through the effort of actually force freezing salt water. They do just what you see here, and that is sail someplace that's really, really cold and the water freezes all on its own, cut off a chunk, tie it to a tugboat, and pull it somewhere where you can capture it. And the fact of the matter is that they do this. They do haul icebergs to places um, that are really hurting for fresh water. It's not a very efficient way, and of course you lose a lot of the water on the way. And then there's a reverse osmosis. So that's where you have salt water on one side and a semi-permeable membrane here that you cause an ionic difference between the two chambers, and the semi-permeable membrane will let the water um, you put salt water into this chamber and it'll let water molecules through the membrane but not salt ions. So when you cause that potential difference, you pressurize this, the water pushes out, the salt's left behind. On this side you have fresh water. And as I said, pretty short and sweet. Thanks for joining me. See you next lesson where we start to talk about energy resources.